Greetings to Dr. Fauzi from Bahardin. Today, my group members and I will present to you our project, Properties of Fluid.
Hello, so my name is Wan Atika Sofia Bintuan Alam, and today I would like to present to you about our interaction, which is thermodynamic properties, kinematic properties, and physical properties. Each fluid has unique characteristics based on its composition and structure. They can be broadly categorized into three different sorts of properties, which is thermodynamic properties, kinematic properties, and physical properties. So to understand the different properties of fluid, first we have to understand exactly its means by the term of fluid. By definitions, anything can flow is fluid. The water we drink, the air we breathe are all examples of fluids. Essentially, all liquid and gas are fluids. So for our experiments, we will learn about the properties of fluids in detail. Next, we move to the type of properties. For properties of liquid experiment, we run 4 experiments, which is density, pressure, viscosity, and capillarity.
Hi, my name is Natalie Chang. Today I will be doing density of fluid experiment. So basically, density is a measure of how much matter occupies a given amount of space. So first, we will go through the apparatus. The apparatus that we're going to use in this experiment is beaker, water, oil, and a few objects. Now we will conduct the experiment. So first, we take beaker and we fill it with water. Add some oil. And dishwasher. And now we're going to leave it for 15 minutes. After 15 minutes, we can see that the liquids separate out into different layers because they have different densities. So the dishwasher soap doesn't mix in as it has the highest density, so it sits in the bottom. Whereas the oil has the lowest density, hence it rises to the top. Now, let's try to drop, if we drop this marble, which is really dense. So finally, we can drop this bottle cap. Finally, I dropped the bottle cap into it, and we can see that it does not exceed the oil, hence it has the lowest density. And the marble drops to the bottom, hence it has the highest density.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Anisha Fika binti Amran, and I will show you how to conduct liquid pressure experiment. But before that, what is liquid pressure? Liquid pressure is the pressure that caused due to both weight and movement of the liquid molecules. The objective for the experiment is to determine the pressure exerted by a liquid increases with depth. The apparatus that we need is a plastic bottle, scissors, and water. Firstly, make at least 4 holes inside of the bottle at a gap of 3 cm. Then, fill the bottle with water until the top of the first hole. Lastly, observe the distance from the bottle that the water jet comes out of each hole.
From the observation, we can conclude that the water jet from the lowest hole comes out with the greatest force and falls at maximum distance. Meanwhile, the water from the top falls at the minimum distance because the water at the bottom receives the most water pressure. This is the result that we will get after the experiment. To calculate the pressure, use the formula pressure equal to rho GH. In conclusion, the water or any liquid exerts pressure increase with depth because the pressure in a liquid is due to the weight of the column of water above. Since the particles in a liquid are tightly packed, this pressure acts in all directions. For example, the pressure acting on a dam at the bottom of a reservoir is greater than the pressure acting near the top. That's a reason why dam walls are usually wedge-shaped.
Hello, my name is Rania binti Muhammad Sufyan. Here I'm going to talk about one of the properties of fluid, that is viscosity. As we all know, viscosity is a measure of a substance resistant to motion under an applied force. And I will conduct the experiment based on the objective we have, which is to measure the viscosity with different samples of liquid. As you can see, this is all the apparatus I'm going to use. First, plastic measuring cylinder, marble, And as a sample of liquid, we have water, oil, and dish soap.
Now I'm going to take a marble and gonna drop one marble into the water. Next, we will repeat the experiment using the different sample with oil and the dish soap. After we already dropped the marble into the 3 different liquid, some of them are very quickly moved to the bottom of the cylinder, while others move very slowly. This is proved by the result that we have obtained. As we can see from the table result, the time taken is different in every 3 sample of liquid.
Hello, my name is Fatin Nashaza, and today I would like to share with you an experiment that will determine one of the properties of fluid, which is capillarity. For your information, capillarity is the tendency of a liquid in a capillary tube to rise or fall as a result of surface tension. The objective of this experiment is to describe how capillarity occurs with different diameter tube is placed in contact with water. Here, I will replace the capillary tube with 3 straws with different diameter but with the same length. First of all, fill the beaker with water. Then, put the 3 straws in the beaker without touching the bottom of the beaker. Stay like that for about 30 seconds. After 30 seconds, we will see the water level in the straw is higher than the water level in the beaker. The narrower the diameter of the straw is, the higher the water level in it.
Based on our experiments, there are relationships between those experiments that we do. In liquids, viscosity increases with increasing density. In gas, viscosity decreases with increasing density. Pressure and velocity are inversely proportional to each other. If pressure increases, the velocity increases to keep the algebraic sum of potential energy, kinetic energy, and pressure constants. Last but not least, the increases in the density of liquid will decrease the height of which the liquid can rise in the capillary tube. So that's all from us. Thank you.